Well, hello everyone, and welcome back to Adrian's Digital Basement 2. Yep, a second channel video, and I have gloves on because I'm going to be touching something that's a little dirty. It's not terrible, but I just wanted to keep my hands a bit cleaner. So this right here, and it's heavy, it's on my lap, is what we're going to be looking at today. Let's try to turn this around. There it is. It's a Sony Multiscan HG superfine pitch. I guess it's obviously a monitor. And it's quite heavy. Let me tilt it up here. It's definitely looks like it's had water on it. It has a musty smell to it. I can see water has run down the face of the CRT. It was in a box when I got it, so it wasn't like I found this on the street. It was given to me by someone local in town. It does have the cable and whatnot. It's all covered in what looks like a little bit of mold. There is the tilt stand for it. Fortunately, this little thing that holds it on, well, it's staying on at the moment, but it's kind of broken. It has these clips that hold it on. 2 out of the 3 clips have broken off. So that doesn't really stay on very well, meaning you put the monitor on this and it will fall off. But I'm thinking if this monitor does work and it's a good candidate for use, I can just put some epoxy on this and try to glue that piece on. You don't need to take that off to separate this. This comes off the bottom of the monitor separately. So I'll just move that off to the side for now. As usual on the channel, I have no idea if this thing works or otherwise, and condition is unknown. There are controls here. Looks like there's a switch for the size, plus V size and whatever, just usual geometry controls. The brightness and the contrast knobs were on the front. We rotate this. Let's pull this power cord out of here so I can move these very dirty cables out of here. So on the back, it's a Trinitron character display, model number CPD-1304. So 13-inch right there. Interesting is the connector here, and I don't know if that's coming across because it looks a little dark in the camera. It is a 9-pin. But the cable that was on there, which is a little frayed looking, has this 9-pin on one side and a VGA connector on the other. So I wonder if this is a multi-sync monitor, meaning it can display CGA and EGA and whatnot. On the top, it's definitely dirty. It's yellow. It's also kind of like sooty looking, like maybe this thing was used so much it might be completely worn out, for all I know. But yes, kind of excited. Multiscan HG. I think I've already said that once. Getting a multi-sync Sony monitor that works well, even if it's dirty like this, would be amazing. I could clean the case up without too much trouble. But if the CRT is worn out, of course, there's no hope there because it's not like Sony Trinitron replacement CRTs for monitors like this just fall off trees. Well, I think I'm just going to go right for it. I'm going to take this power cord and plug it in, and we're going to turn this thing on and just see if it actually works. I have this, I validated that the switch in the front is powered off. Okay, mains are connected and no smokes yet. Of course, it's off, but you never know what's going on. Nothing is connected, but here we go. Let's turn this on. Okay, a degauss. That loud buzz was a degauss. And I do hear high voltage. There's some static electricity here. So that is good. Okay, we're getting an image. There is a raster and it's very green, which is a bad sign right there. It's rolling a lot in the camera and it's flickering to my eyes. Let's see about these knobs here. So that knob does nothing. In fact, both knobs do nothing. Definitely, I'm going to turn this off. This definitely doesn't seem like all is well. In fact, did you notice when I turned it off, as the raster collapsed, it collapsed to a green line in the middle? I would imagine if the CRT were in good shape, it would have collapsed to a white line. But it definitely doesn't. There's a little bit of green or blue in there, I'm sorry. But yeah, okay, so I'm not holding out a lot of hope. That seems like a weird thing for a monitor to do when you first turn it on, but I've never used one of these. So I think I need to get the cable and take a look at it, see if I can figure out the pinout or if it's even workable. It says Sony SMF523 on the ferrite bead there. As I mentioned, one side is VGA and the other is 9-pin. So I'm just doing a little bit of quick Googling, looking for information on the old CPD-1304. I found something that seems to indicate that it runs up to 1024 at 48 kilohertz. So VGA is 31.5 kilohertz, so interesting. I'm just looking to see if I could figure out pinout on this cable. All right, I have the Pentium test bench connected. I think the cables are all good. So we'll power this on again. There's the degauss. That's working at least. And once we get that raster, wait a second here. Come on. There we go. All right. Oh, that is sad. That is a sad, sad image. It is so bad. Okay, so the brightness and the contrast do work. Barely. Well, not barely. Wow, look how bad that looks. That is unbelievable. It is so blown out, so blurry, it's just overdriven. I need to crack this open. I mean, it's not all lost. Maybe the problem is some of the pots for adjusting the drives have gotten corroded or need deoxit. So I'm not writing this off yet, but I'm not holding out hope at that horrible image quality there. That just looks super bad. So let me crack the case open and we'll look inside. I am curious if there's going to be horrors in here. Oh, yep, well, definitely looks like it's very, very, very well used. See this here? That is an indicator of high hour usage. So a worn out picture tube, it's completely expected. Well, looking around inside, nothing looks immediately out of the ordinary. So this is kind of cool. This is the RGB information that goes to the neck board, and it's literally, they're using coax cables here. So that's cool, just for the clearest possible picture. There's a hybrid there. Control board. Like I said, it's very apparent that this monitor is very well used. I'm just gonna pop off the back cover here. It is soldered on one spot there. Okay, there we go, it's fine. Okay, so we're gonna look at the back here. There are some controls here and they're not labeled. That's so unlike Sony that they didn't put labels. So there's 2 pots here, there's a pot there, 2 pots there, and there's 1 pot over here. Not to mention there is screen and focus, which are labeled. So I can turn down the screen at least, which should make it a little less blown out. But these obviously are the drives for the cathodes and stuff, but it shouldn't be incredibly bright like it was on green. So it's almost like there's a short inside the CRT with this thing. And I hope this comes across, but it is fascinating. So the video connector, the input connector is right here, and the RGB literally goes right from this little PCB that's on this 9-pin directly to the neck board. And there are some ICs here for processing and stuff, but the sync stuff, which is this wire here, goes over somewhere else. So definitely this board here is what's processing the video signal. So the fact that it looks bad means basically there's either an issue probably on this or the CRT itself is bad. Also, this is interesting. I need to try to turn this so you can maybe see this. The neck board here is actually clamped on to the CRT right here with a clamp. So this just can't come off. And I guess they did that because it's relatively heavy, this thing. And if the monitor got dropped or whatever, it'd probably just break the connector off. Although all the weight is on the glass right here. This is a weak part of the CRT. So that's interesting because I was trying to move it. I'm like, it is not budging. And when I looked, I saw the clamp there. All right, so I've been fiddling with the controls a little bit. I'm turning the monitor on right here. It's hooked up to the computer. Unfortunately, I turned down the screen, so now we don't have that bright, solid green raster that's showing up. But at this point, we have a pretty blurry image, and it's just completely green. On the neck board, there are some potentiometers for most likely the red and the blue because they are colored red and blue, but adjusting them does absolutely nothing, has no effect. There is one pot on the side which does have an effect. It's this one here, and this is almost like a sub brightness or something, because these controls on the front, they do something. See, they are changing it. But this one here, and then the raster starts to show up. Yeah. Oh, there's a switch on the side here. I should flip that switch, see what that does. Let's see here. Where is that switch? Here it is. Oh, that just changes the geometry. Okay, that's what I thought. Now, looking closely at the text, actually, it's not horrible. Wow, that's pretty bad. That text is pretty blurry. This text is okay, sort of. But I really just need to figure out, is it the CRT itself that's completely sad? Now, when I turn it off, we just get green. That's right there. It's basically telling me that this CRT is pretty much dead, and we only have the green electron beam working, and the other ones just don't work at all. So these coax connectors here, I thought about trying to remove one. Okay, so this is the green one, right, that comes from the video signal. Let's just plug this red one into the green socket here. And let's see if I can get that back in there. These are very fancy little coax connectors. Come on, there we go. Okay, I'm gonna leave the green one off just to rule out that maybe the VGA cable that I'm connected to is bad. So we just wanna make sure that we are actually getting a red signal and it's going into green. If we just still see green, then I know that the cabling is good. There's no issue there because we're actually getting a red signal. It's just not making its way into the CRT. Okay, here we go. Powered on. I'm expecting a green picture, completely green. Totally green, there it is, green. It's exactly the same. So I know it's not the cable that's causing the green image. This is definitely coming either from the CRT or this neck board has some kind of a failure on it. All right, I loosened the clamp and I've taken the neck board off. I'm just gonna put these coax connectors back to where they should be. But look at this tape. That is baked. That is so baked. So I'm imagining that, yeah, like the number of hours that this thing has been used for is a huge number. And that has just rendered this CRT completely dead. Now that I have this off, I'm gonna go look to see, look at this little cap on here. I'm gonna go look to see if I have the connector for my CRT tester, because that's the quickest way to rule out if it's this or if there's some electronics in here. This thing doesn't look too hard to get apart. There are some electrolytic caps and stuff in here. So it is quite possible that some of those have gone open. Let's unplug some of these cables here. It'll take a little bit of effort to get this thing apart actually because, well, yeah, it's like I have to take these screws out. There's obviously some heat sinking going on with this thing. I can see discoloration on this board too, so it's baked. But potentially if there's any caps like in this area, I'm not seeing, oh, there's definitely, that's an okay, there's electrolytics in there. Maybe those are dead. Also, for hooking up my CRT tester, Sony was nice enough to label this board here. So we have the blue cathode, green, red, G1, G2, G4, which is focus. Here's heater 1, and there's heater 2. So there's the heater. So I can actually just clip right onto this using this pin out here. So I'm gonna go break out the tester and we'll see what it says about this thing. Well, I went in my kit and I found this one, and this actually might work. Is that possible? How's that possible? How could a non-Sony connector? No, that doesn't actually work. Feels like it wants to work. It's like it almost fits, but not quite. Okay, I just need to get the old clip leads out. We'll do that. I have my harness all labeled here, see, red, green, blue, so it'll be easy for me to just go from here to this. So I was starting to hook up the tester and I decided to abort, only because I'm pretty sure that this CRT is dead, so I would just be confirming that. But there's also another reason. And it's this right here. I actually have another CRT. And I think it's completely going to be compatible with this one. So this part number here is M34JNQ10X. And the one on this monitor is an M34JNQ15X. So there's just that slight difference there with the 15 and the 10. And I think that difference is entirely, well, I'm not sure. I was going to say that this seems to have an anti-glare etched coating on it. And this one, which is really dusty as well, is shiny. So I think that might be the only difference. Now this may be shiny too, and it's super dirty. Let me try to clean a little spot off. That is dirty. So let's let that dry for a sec. And yes, as this dries, it's etched glass, meaning it's anti-glare, right? It's not shiny. That's probably the only difference between these two. The deflection yoke looks completely different. This came out of not a Sony branded monitor, so this is probably different. I don't know. I'm just going to spend a second here to give this CRT a little bit of a clean because it's filthy. So the deflection yoke on this CRT right here has just a single cable with 4 pins. This one, on the other hand, also has 4 wires, but it goes to 2 different connectors. So I'm going to say that I'm going to need to remove this deflection yoke entirely and swap it, which sucks. And that's because, so see all these little things here, and this is a magnet. These are little kind of strips that deflect or change the magnetic field that comes out of this. And unfortunately, when I take this deflection yoke off, the deflection yoke, this one, when I put it on here, there's a lot of magnets and stuff on this CRT, and I may have to transfer them. But then it also varies just the shape of the CRT, and there's a whole art to that. So this may not be a very good process. This might result in pretty blurry images that just don't look good. Convergence might never work properly. But to be honest, this is an extra CRT anyways that wasn't in anything. And this one is dead. So the reality is this monitor is going to get trashed if I can't have a successful swap here. I have everything reconnected. What I'm gonna do is, I was gonna try to turn down the drive controls. These are the drive controls here. Okay, I don't know. Not sure which way is down. I'm assuming counterclockwise is turning it down. This is the blue and red drive. This is the blue and red bias. I can see it if I just look through the holes there. You can see the writing. I don't know why they didn't put it on the back of the PCB. It's on the top side. Anyhow, okay, so all the little cables are connected here. I mean, this should be good to go. This should be good to go. So I'm going to carefully put this thing back down on its bottom so we can see it. There it is. A little dusty. The CRT is so shiny and clean compared to the rest of this monitor, which is so brown and dirty and everything. So, okay. Gotta get this plugged in. I guess the first thing is to do is just plug it in with no signal, see if it blows up or whatever. I actually don't know if this CRT even works. It may not. It may not actually work. It was pretty dusty, but it was untested. Okay, here we go. Okay, well, I had it on. And there's high voltage. And let me just quickly look to make sure I have everything okay with deflection. Because if there's a line, I need to turn it off immediately. We have high voltage. It's a static. Okay, okay. Let me turn off the screen. Okay, we don't see anything. But that's okay, because I have all those controls all the way down. So, let's turn this way. And I'm going to turn up the screen, and hopefully we're going to see some kind of raster. Okay. We do, and it's all green as well. We can ignore this blue corner here. That is just a problem with the magnetics there. Wow. Okay, well, I guess I jumped the gun. Okay, actually, hold on a second before I go all crazy. Yeah, that's not doing a thing. That's the blue drive, and that's the green, and we're getting nothing. So it was the drive board. It's actually, it wasn't the CRT. And look at all this mess over here. That comes from, see, it's affected by just moving around the yoke. All right, well, let me hook up the computer to this and let's just see about the sharpness, because that other monitor was pretty dim and it was pretty blurry. All right, the computer is hooked back up. Let's turn this so we can see it and I can adjust it. Power on. Okay, turn on the computer. Okay, it's way too bright. Let's turn down the screen control. All right, so clearly it's all green. So that means the cathode drive on that neck board is not even driving the blue and the red. But I can say that this text is super, super sharp. It was not on that other screen. It was very, very blurry. This CRT is clearly in much better shape. Uh-oh. One of the buttons is, one of the knobs is off to the side, so I'm gonna have to fix that. But this knob here obviously is working, and yeah, that looks really sharp. So I'm definitely not out of the water yet, because without the blue and the green, I have no idea if the convergence is a disaster right now. And obviously the yoke is just roughly on here. It's not even, I don't even have it attached properly. And that's because I'm probably gonna have to move around those rubber pieces and all the magnets and stuff. But the fact is, it's a nice, sharp, clear image. So now it's just a matter of figuring out what's wrong on the cathode drive board to get those other colors back. And theoretically, I should have a nice, clear Sony Trinitron monitor, a 13-inch, which is something I've been looking for the longest time. All right, so you see that the board is uncovered. And when I uncovered it, I noticed this section of the board looked very baked. Remember how that tape on the CRT was so baked, so this gets really hot from usage, and it rises up and it bakes this part of the board. Well, what's here? There's 4 electrolytic capacitors. Also these resistors, which probably get really hot. So I checked the resistors, they're fine. And then I checked the capacitors. And I tested them in circuit using my LCR meter here, DE5000. I just clipped onto the caps while they were in the board. And of these 4 capacitors here, 3 of them were totally dead. The top 2 and this one down here, basically almost doing nothing. Well, when I trace the 2 capacitors on the top, what they go to these 2 potentiometers among these other parts here. And what is that? The red and the blue drive control. Interesting. In addition, this capacitor over here, which is this one, 47 microfarad, 100 volts, it was also dead, just registering nothing. So these are the dead capacitors. I've taken them out of the board. I actually took out the 4th one here that wasn't dead. It actually was showing okay, but I figured these 3 were baked and they're all the same value, same brand. That one is going to be close to death anyways, so took it out as well. So I replaced these 5 capacitors. This one I had to take off another monitor because I didn't have that particular value, although I found a second one here that also tests fine now. And the one I put in I think might be too tall, so I might have to swap it out for this one. 3 of these I found in another monitor, and 1 I actually had in my parts bin. So I'm going to plug this board back in, unshielded, without that chassis thing on it. And there's a chip here, this one right here, that connects via heatsink compound to right here. So clearly it gets hot. So I'm not going to run it like this for very long, but just long enough for testing. I also fixed the brightness knob here, which is just out of alignment, so both knobs are good now. And let's give the monitor a try. First, I'll make sure it's off. Okay. And we'll plug in this very dirty video cable here. The controls are completely out of whack, so I'm expecting things to look terrible immediately, but I can definitely fix that. So here we go. Gonna get ready to turn this off in case I forgot to hook something back up. So far, not seeing anything. Oh, wait. Okay. It's all very crooked. But that's okay. I'll just turn that. Okay, whatever. All right, let's see about these controls here now. No, they're still dead. They are still dead. That is annoying. Sub brightness, sub contrast. There's these controls right here. There's bias. Nothing. Oh, I thought that this might be the fix. This one on the side here is actually the green bias, so that's why that has an effect. Oh, well, let me turn up the screen control. Okay, so this is the screen control. Yeah, unfortunately, we still only have the green. Darn. Dead capacitors. I thought that would be the clincher. But still, no joy. If I turn this off, we'll just have the green. There it is. So definitely nothing is coming through the blue and the red. You know, the thing that concerns me is what if it's those drive ICs? I mean, if it's that, there's no fixing this thing whatsoever. All right, so I need to keep poking around on there and testing things. To be honest, I stopped testing the caps. There's more caps on there I didn't actually test. And that might well be the problem as well. Those could be similarly dead because there are more electrolytic caps and, you know, bake. It all bakes. So there's more caps over on this side. I only dealt with the caps on that side. This IC obviously does some video processing, whatever. So the RGB comes through here. These are the coax connections. There's some resistors, there's some diodes, and there's some disc caps. There are more electrolytics here and here. These caps here are 47 microfarad, 25 volts. So are these 2. And what's this one up here? All right, so all the caps on this side are 47 microfarad. So I'm just going to quickly go through and mark off any that are out of spec. 400 nanofarads? What? That cap looks dead. Okay, this one is okay. So the bottom one is fine. Oh, and guess what? The bottom one that's fine? Green. You gotta be kidding me. All these caps are crap. Oh, this thing is coming apart. I'll need to fix that. Let's check these ones, 47s as well. That's fine. That one's actually totally fine. And one more down here. That one is bad. Unbelievable. Unbelievable. So many bad caps. So this one is bad, that one is bad, and that one is bad. So 3 of those are bad. They're all the same value, so I might as well change all of them. Those ones right there. What junk? What utter junk? I still don't know if this is actually going to fix it, though, because I can't see how, if these are bad, that would make, when I turn the screen up, I'm not getting anything. That doesn't seem correct. Like something's going on with the driver, I think. I checked all the caps on this side here. They're fine. So it's this side of the board where the issues exist. All right, the new caps are in. There were actually 6 over here. This one was dead too. So I think of all of these, the one green cap was okay. And also one down here. I forgot which one it was. So it's kind of funny in a way that the green cap on this side and on this side was fine, and the blue and the green on both sides were bad. Very strange. I don't quite get that. Now, in case this thing is totally dead, I just put brand new caps in here. If there's a problem on this board I can't fix, like these ICs, I didn't cut the legs off here, so I'm gonna pull those caps out of here. Well, this monitor will become e-waste anyways. I'll save this CRT because clearly it seems to work well. But I will e-waste the rest of this thing. Well, and when I say e-waste, I usually keep parts of it and I use them as spare parts when I go to fix other things. That's kind of my typical behavior. I have a box full of old monitor parts on the floor right next to me, and that's actually where I got like some of the caps I needed off of old CRT boards, because 100-volt caps, for instance, not something I normally keep in stock, but 100-volt caps are on monitor boards, so that's pretty typical. All right, so I'm going to plug these coax cables back in. They're quite fiddly to get back in properly. I think that is everything. Yes, everything is connected back up. So let's carefully get this back on the CRT. Okay, my little pile of dead caps there. Let me move these new caps out of the way. I have to remember I keep a little inventory of caps so I know how much to reorder, and I just used up 6 of the 47 microfarad. They're Nichicons. Okay, let's spin this around. Let's plug the cables in again. What are we gonna get? We're gonna get a working monitor, or are we gonna have the same problem? The worst thing is, I think I have quite a bit of work ahead of me, even if this fixes it, because switching the CRT and the yoke and all that stuff, there's going to be a lot of convergence issues. All right, here we go. What's going to happen? I have my finger on the power button. And it's still just green. No difference. This is just wild. How could so many caps be bad? Let me just fiddle with the drives here. Nothing. Just a big fat nothing. Bias controls, same thing. Nothing. This just doesn't make sense. All those caps were bad. Changing them out, and it has literally no effect. None at all. And I know if I turn this off, we know it's not just an RGB theme because we're going to get the green collapse. Yep. Okay. Keep looking. Okay, I think I figured out the problem. Let me turn on the monitor. See if it works. Oh, the computer's already on. What's going to happen? Oh, yeah. Look at that. It is actually working. Unfreaking believable. Of course, as I suspected, convergence is not looking so great, although it's actually better than I thought it was going to be. But yeah, I can't believe I figured out the problem. Awesome. Okay, let me go explain what actually was going on with this thing. Let me turn it off. So let me pop off this board. To be honest, I should disconnect it because I gotta put the metal chassis stuff back on now that this is fixed. Okay, so remember when I turned on the monitor for the first time and the screen was really, really green, like super bright? What I didn't know is if anyone had ever messed with the controls on this monitor, right? Like, I mean, I've never seen this monitor before, who knows, right? I guess I just assumed the controls were out of whack. So I turned the screen control way down so that green, full screen green went away, but then all the text was green. Okay, so after I changed all these caps and there was still no blue and green, I started suspecting maybe this chip or this chip were faulty. So I broke out the oscilloscope and I started looking at the signals as they passed through. And definitely I could see red, green, and blue all passing through this IC. And then this is like a driver IC that kind of generates the higher voltages to drive the actual electron beams. So I started looking at the input of this and I saw signals for all three colors. And I looked at the output and I actually saw signals for all three colors. So I knew that chip was fine as well. That was on the oscilloscope. Then I took a look at the cathode signals for all three of the cathodes. And basically a cathode on a monitor like this makes it full brightness of that particular color when it's at ground. If it's at a high voltage potential, it's the equivalent of off. And it can be anywhere in between there to get a varying shade. And the bias control sort of adjusts the overall offset of the entire thing. I could actually see on all three the signal getting through to the CRT, but the reason why I wasn't seeing anything on the CRT for red and green is because the voltage on those two pins was quite a lot higher than on green. Green was much closer to ground. I remember when it's near ground, that is brighter. So that totally explains why everything was super bright on the green and visible, but I had to turn the screen way down and I couldn't see the red and the blue anymore. Well, I knew that if, say, I disconnected the green entirely and then I turned up the screen, I would actually see the red and the blue totally fine, like they were working. And I could turn the bias control and I could turn the drive controls, and on the oscilloscope, I could see the bias adjusting it, I could see the drive increasing the amplitude. So it totally, red and green were actually behaving completely normal. So then that made me think that when we first turned on this monitor, the whole screen was green. Remember that? Just totally green. I kind of assumed that someone had messed with the controls, like they had turned the bias or the drive or green all the way up or whatever, right? I turned down the screen to kind of fix that problem and get rid of that overall green picture, but then we didn't have any of the other colors. So that kind of got me thinking that the problem actually probably lies with the green bias control, nothing to do with the red and green at all. Those seem to be working normally. Something on the green bias was bringing the entire signal much lower than it should. So the potentiometer, which it's right here on this side of the board there, everything checked out. The ohms range on that matches the other two pots right here for the other two colors. So that pot was working. And plus I could see it changing the picture when I adjusted it. Something else was bringing it down to ground. Well, there's a 180 volt rail that comes in from this cable right here. And that kind of comes through the circuit. That 180 volts is what brings those cathodes up away from ground so that they don't light up the picture tube, right? Well, right near the potentiometer, there was a capacitor that was connected to the 180 volt rail and to ground. And remember, the problem I was seeing was that the entire bias for green was pulled closer to ground than it should be, even though I had the potentiometer like set to the middle, just like the other two. The cap in question was this one right here, and I think it's this one on the desk. All right, so the capacitor in question was this little jobby here. It's 1 microfarad at 250 volts.
And this is what was connected between the 180 volt rail and ground. Okay, so I grabbed my LCR meter, and this was in circuit. I was testing this. And there it is, 945 nanofarads. And the D value is 0.29, which is not bad considering this is actually a 250 volt cap. So it looked okay on the tester, but it sure wasn't acting okay, this circuit. When I analyzed the bias circuit, and I mean, I have a rudimentary knowledge of this. There's a transistor, there's a potentiometer here, and there's a 180 volt rail, and there's some resistors. And it looks like what goes on is the potentiometer changes the base on the transistor to basically bleed off some of the 180 volts to ground. Depending on how you adjust the pot, adjusts how that bleeding is going on. Well, with this cap installed right here between 180 volts that feeds that transistor and ground, this was the only thing that made sense, that if this was, say, leaking, like I had leakage at the higher voltage, that it would actually leak to ground from the 180 volts and it would pull the whole thing down. So it would pull it down more than you intended with the potentiometer and the transistor. So I took this out of the board, and as we saw in the tester, it actually looks fine. But I assume this thing only tests at a few volts. So it's not good for testing leakage. So I went into my parts bin down there and I started looking for a cap that was high enough voltage. I don't have anything in the 250 volt range. And I knew it's 180 volt rail, so it needed to be at least 180 volts, but preferably more. And the one I ended up finding was on another old CRT board. Is actually a 450 volt cap at 1 microfarad. And when I tested that, tested fine. So I installed that, plugged the board in, and we just saw the results. That fixed it. This cap, which tests okay, was literally pulling down that rail closer to ground, which caused the bias to be all out of whack. And that was definitely the problem right from the start. I mean, there were a bunch of dead caps on this board for sure, but absolutely that bias problem was what caused that super green screen when I first turned this monitor on. Now, unfortunately, that original CRT definitely is not dead. That green is not caused by that CRT. But I am positive that CRT was still worn out. This monitor's been used a ton. I could just tell by the amount of black soot and dust. And definitely the text that was showing up on there was very blurry. When I got this new CRT in here, I guarantee you it was nice and sharp. And now that this thing is working and I was actually displaying correct text there, even though the convergence is off, it looks nice and razor sharp, as it should. This is a Sony Trinitron. It would have been a very expensive monitor when it was new. So what's left for me to do now is put this neckboard thing back together, put some heatsink goop on there so it stays nice and cool, clamp it back on here, and then unfortunately I have to start fiddling with the convergence and the yoke and stuff like that. I mean, I got the purity looking pretty good already. Like if we show a full blue screen, it looks good. There's no weird colors in the corners, but definitely the convergence is off. But static convergence is a little easier to adjust. I left all of these magnets and things on here from the other, whatever it was in before. So hopefully I don't have to touch any of those to get the corners and stuff working, looking a little better. There's a lot of them stuck on there. Clearly there's an art to that. But yeah, so I'm hoping I can at least get a nice, good quality CRT out of this. I will need to clean this monitor. It's pretty filthy. I'll need to fix the cabling because the cabling is sort of frayed and coming apart. And I got to glue that stand back together. But a 13-inch Trinitron that is looking good, that's excellent. Now, there may be more bad caps on this monitor. I mean, the fact that so many were bad on here, yeah, that means there could be a bunch more. So ideally, I need to kind of get the LCR meter and go through all the caps and find any other ones that are bad. But these other ones that are on the rest of this board don't affect the picture quality. They would just affect geometry and stuff like that. And right now the geometry seems fine. So there we have it. There is a little repair on a Sony CPD-1304, a tube swap, and then diagnosis of a problem on this board and a bunch of bad caps and all sorts of issues and troubleshooting. And yeah, so this video is way longer than I ever thought it was going to be. But I hope you found it interesting. I hope it made sense. I'm sorry for the bad camera work here. It's second channel video. I don't spend as much time zooming in close on things. But put some questions in the comment section if you want me to explain a little bit better about how I troubleshoot it and stuff. But yeah, that was basically it. This is the pile of dead caps here. Oh, I still might have to switch out this cap here for this shorter, lower profile one, just because I think this one won't fit. But that is it. So, thumbs up if you liked it. Subscribe, please, on the channel. That would be fantastic. Check out my main channel. Thanks for all my patrons. Really appreciate it. You can become a patron. There is a link in the description below. That's it. Stay healthy, stay safe. I'll see you next time. Bye-bye.